Alrighty, so now we're going to start on the 8A notes. So I'm going to work my way through this. We're going to start off with a couple of vocabulary terms to start with. Okay, this is normally, we always call it the square root symbol, because that's normally what it's used for. But in general, it's really called a radical. So we're just going to call it a radical. The reason why it's called a radical, this up here is the index. We'll learn about that in a minute, but this number can change. Normally we're doing the square root, which implies it's a 2. Okay? The expression written underneath the radical is called the radicand. So there'll be a couple questions. Identify the radicand, and we'll even have one in the notes. It's a pretty good question to have. All right, so now the next one is the principal. Oh, sorry, I misspelled that. The principal square root of a non-negative number is its non-negative square root. And we'll talk about that more again. Basically what it's implying is if I were to do the square root of 16, that is implying it is positive 4. To get the non-principal square root, I would have put the negative square root. I'd put negative square root of 16. That is negative 4. The number C is called the cube root of A if C to the third is equal to A. Alrighty. And then I kind of introduce this a little bit. There's different numbers in here, the K, and we call this the index. It's whatever this is. So normally, like I said, we're going to do the square root of 16. I would never write a 2 there, but that's what it is. The square root of 16 is 4. Now, for anything greater than 2, the index always has to be 2 or greater. So if I would do this, it would be the third root of 8 or whatever number you want to type into the calculator. But again, this 3 is called the index. Okay. For any non-negative real number, a, and any natural number where n cannot equal 1, a to the 1 over n means the nth root of a to the first power. This is something we'll be playing around with quite a bit. Okay. So the non-negative nth root of a. Okay. And they always say non-negative because they want to try to make sure everything's positive. Okay. And then for any natural numbers m and n, any non-negative real number a raised to the m over n is really the nth root of a to the m power. And so if we look at this, these two things go back and forth here. We notice a to the 1 over n is the index, so it's the nth root of a to the first power. If I look at this here, okay, I look at a, the index is on the bottom, so it's going to be n, and then it's m on the top. And we'll be practicing that a lot, so you'll get to see more of that. Okay. And so now here, we're going to start attacking some problems here. Now the principal square root, in other words, if I'm doing the square root of 289, that is just positive 17. There's nothing written out here, but it's implied that it's a plus. Now the negative square root, it's still the square root of 289. I just put the negative out front, so this answer will be negative 17. And so when I get down to more problems here with regular numbers, there's a negative out front, so I should be able to handle the square root of both of those. The answer is negative, and it's 7 over 3. So this, the square root of 41, you really need to type this in on the calculator here, unless you have your squares memorized that much, but it is equal to 21. And since there's no sign out here, it's implying that it's a positive. Okay. All right, and the other thing I did want to just quickly look at, if I were to write this as the square root of 21 squared. If I use my m over n that I did on this right up here, if I look at this, rewrite it using that, remember there's an invisible 2 here, so this is really 21 raised to the 2 over 2. Well, 2 over 2 is just 21 to the first power, which again is just 21. So I'm just trying to put that in there here. Now the square root of negative 9. If you were to type this in on your calculator, the square root of negative 9, it says it does not exist. It's not a real number. Now in 8C, we're going to learn how to use imaginary numbers, but again, that's 8C. So right now, this is just not a real number. That's all they want to do for this first section. Like I said, those of you who remember, when you have the square root of a negative number, it's really an imaginary number, and then we go from there. Now this next one, this is really typing on your calculator here. If we were to type square root of 22 on most calculators, it will just give you 4.6904 and a couple more digits. Now the TI-30XS Multiview that I recommend everybody type in, if you literally type in the square root of 22, it will only give you the square root of 22. It won't give you the decimals. If you want decimals on this, you have to type the square root of 22 and then actually type the decimal button. And then you will see the answer worked out. So if you have to give the decimal, please make sure you got to type the decimal. That took me a long time to figure out. Drove me crazy many, many times. But that's all you got to do to get the decimal. Now, all other calculators will just solve that for you. Right. Here's the one that I talked about in notes. Identify the radicand. The radicand is what's underneath the square root. So it's just x cubed plus 6x. And that's all you got to do. For this next question, we got to find the domain and the indicated values. Now, as I just said up here above here, change my pen color. If I look up here, I can't do a negative number under a square root. And that's what this is. So underneath here, we're going to worry about the domain. Now, if you remember in the last section, when we had a fraction like 3 over x plus 4, all I had to do was set the bottom equal to 0, and when I got x cannot equal negative 4, so my domain was all real numbers except for negative 4. So now in this case, this underneath the radical, or the radicand, must be greater than or equal to 0. So all I do is I make a little equation greater than or equal to 0, and then I solve for x. So I subtract 4 from each side. I get 2x is greater or equal to negative 4. Divide each side by 2. I get x is greater than or equal to negative 2. So, as long as x value is greater than or equal to negative 2, I will get a real answer. If it is less than negative 2, I will not get a real answer, and I'll get not a real number. So when I put in 6 here, I'm going to do the square root of 2 times 6 plus 4. Now 12 plus 4 is equal to 16. I do the square root of that, and I get g of 6 is equal to 4. And if I look at 16, which is underneath here, is bigger than negative 2, so I would get a real answer. Now when I do negative 8 is definitely less than negative 2, so I should get a not a real answer when I do this. Let's type it in here. Square root of positive 2 times negative 8 plus 4. Negative 16 plus 4 is equal to negative 12. I cannot do the square root of negative 12, so it is not a real number. Okay? But this is the key here. When I'm telling the domain, I just have to make underneath the square root greater than or equal to 0. And then I can just look at these things to see if it's a real answer or not a real answer. So let's go to the second side here. And we'll do a couple questions in here, and then I'll take a break here. All right, so find each of the following. Assume that the variables can represent any real number. Use absolute value notation when necessary. Now this is only in section A they're going to try to do this and trick us. What they do in B is they assume all real numbers are always positive, so we don't have to worry about the absolute values. But remember, anytime we have an even index here, like a square root like this first one here, it has to be positive. Now there are no letters in this, so there's no thing, but there's really an implied positive here. So this is really just 5/8. And you should be able to just type this on your calculator as well. Now this next one, this is still an even index here, so it's a 2, but there is a letter in here. So we have to make sure anytime there's a letter, it has to be positive, so we have to use an absolute value. Anytime this index is even and we have a letter, I'm going to have to use the absolute value. Now, for the square root of 9, that's simple. That's just 3. Now we have to do the square root of y minus 1 squared, but if we think about it, it's really y minus 1 to the 2 over 2, which is just equal to y minus 1 to the first power, just y minus 1. But there's a letter here, so what I have to do is I have to put it in absolute values. Okay? Anytime there's an even index with a letter, I have to use absolute values. All right, this next one here. This is a cube root, so it's an odd index. So if there was a letter, I would not need absolute values. But on this one, there's no letter, so I don't have to worry about that anyway. But how do you type cube root? Now, it depends on which calculator you have. If you have the TI-30X Multiview, like I try to tell you to use, you got to type the 3, then you got to use the second button, and then you got to hit the raise to the certain power button, and then you would type -64. And when you type this, it should look like the cube root of -64. Now the other TI-30 that I lend out, those light blue ones, it will just look like this. When you type it in, it'll look like this: 3x root, and then in parentheses -64. There's only one negative in there. But that's what it'll look like. But either way you're going to type in, you should get -4 as your answer. Now this is an odd index, and there's a letter in here, but since it's an odd number, I do not need absolute values. And then really it's just 7 over 7, so that's really 1, so it's really just negative. Then just leave x plus 5. So now the computer will take this answer. Now if you want to distribute the negative, it should take -x minus 5 as well. Either answer should work. Okay. This next one, we have a letter in here, and there's nothing written here, so that's a 2, so it's an even index. So we're going to need absolute values here. Now when I do this, -6x squared, -6x times -6x is 36x squared. So I'm really doing the square root of 36x squared. If I multiply this out, the 36 is just 6, so I don't have to worry about that being inside the absolute value because 6 will always be positive by itself. Then I have to do the x in absolute value. This next one, we have 4, even index. There's a letter in here, so I need absolute values. Now this is the 4th over 4. So again, the 4 over 4 reduces to 1, so it's just x plus 3. Okay? Again, even index, I need absolute values. Almost the same question as before, but this is an odd index. Odd indexes do not need absolute values. So again, if I put the 5 over 5, it's really just x plus 3, isn't it? I don't need anything. Odd indexes don't need absolute values. Now this next one, we have to remember some factoring here. What factors of 49 add up to -14? Well, you should see 7 and 7, and since it's negative, and we could almost predict this, this is the square root of x minus 7 squared. So again, there's the even index here, so it's 2 over 2. Again, that's an even number, so it's got to be the absolute value of x minus 7. Now this next one, we've got to type part of this in the calculator. The cube root of negative 27 is just negative 3. And the cube root of x cubed is x. Since that's an odd index, I do not need absolute values. And then they'll start doing some plugging in some numbers here. So if I plug in f of 3, that means x equals 3. So it's the cube root of 3 minus 4, which is the cube root of negative 1. Now since this is an odd index, negative numbers are perfectly fine. I do the cube root of negative 1, and I get negative 1. And you can type it in your calculator to prove that for you. Alright, so I did the first 2 pages, so I'm going to stop here, and then I'll continue on the next part.